Hello, everyone, and welcome back to your channel of Math and Engineering Made Easy. Today, in the second session, we are going to start with imaginary numbers. So, what are imaginary numbers? You learned that when we take square roots, for example, of any number, this number has to be non-negative. So I say square root of 4 is 2, square root of 9 is 3, square root of 0 is 0. But what if I give you a negative number and I say, what is the square root of -1? Say, what? I don't have any two numbers that when I multiply, I get a negative value. It has to be positive. I say, yes, it has to be positive if the number you are talking about is real. It's real? Are there numbers that are not real? Yes, imaginary numbers. In the beginning, that was an introduction so that we can deal with cases. For example, remember when you solve the quadratic equation and you say x equals negative b plus or minus the square root of b squared minus 4ac. The quantity square root of b squared minus 4ac, or more accurately, the b squared minus 4ac, we call that the discriminant. And we will see, if you review that later, that if that value b squared minus 4ac is greater than 0, you will get two distinct solutions, and both of them would be real. Maybe like 4 and -5, whatever, two values, two different values. If b squared minus 4ac equals 0, you get a unique value twice. So you get -7 and -7. 15 and 15, 0 and 0, just the same value twice. But you have to have two because it's square, meaning you have two solutions. But what if b squared minus 4ac is less than 0? How do you take the square root of that? These are the imaginary values, and we are going to talk about these, but today we will introduce them first. So mathematicians agreed that instead of writing negative square root of negative number, they said, okay, let's call the square root of -1 I. Maybe if you have a sibling who is taking electrical engineering, it will tell you, no, we call it J. Well, it doesn't matter, but these are like just a few differences between fields. But the square root of -1, we call it I. So if I square both sides, the left-hand side, the square root and the square cancel each other, and I get I square equals -1. And then if I take I square equals -1 and multiply both sides by I, the left-hand side would be I cubed, and the right-hand side would be -I. -1 times I is -I. And then if I take I cubed equals -I and multiply both sides by I again, the left-hand side would be I to the fourth. -I times -I is -I square, but I square is -1, so it's -1 times -1 equals 1. And then the cycle repeats, which made it easy to evaluate I to any power. So if I tell you, for example, what is I to the power of 73? I say it doesn't matter. Every time I divide by I to the fourth, it's like dividing by I. But what is 73 divided by 4? If you try it on the calculator, you'll get 18 and a quarter. In fact, 72. So I say I raised to the power of 72, and since 72 is divisible by 4, I will go over this cycle 18 times. Multiply by I until you get 1. And then I to the fifth, 6, 7, 8. And then 9, 10, 11, 12. At the end of the day, this thing is 1 times I, so equals I. So all what you have to do is to divide the exponent of I by 4. If you don't get any remainder, that's 1. If you get a remainder of 1, that's I. If you get a remainder of 2, that's negative 1. If you get a remainder of 3, that's negative I. And then, oh, I'm sorry, I wrote negative 1. Negative I. And then that's it. In fact, sometimes they tell you, okay, so what if I divide by a number that has I? For example, what is 4 over I? I say, I don't know. But you know what I can do? I can, like we did before with uh, irrational numbers, I'm going to multiply top and bottom by I. The numerator would be 4I, and I squared is negative 1, so I get negative 4. So whether I multiply or divide by I or powers of I, by using this simple approach, you can simplify it as much as you can. Now, I have a worksheet that looks like problems that you may get about imaginary numbers in your Regents exam. So the first one says, given I is the imaginary unit and A equals I cube and B equals I square and C equals I, which expression is equivalent to this? So they tell you A is I cube. But did you remember what we said about I cube? I cube is negative I. I cube is negative I. So I can write this as negative 2ix squared, right? Because A is negative I. B is I squared, but I squared is negative 1. So minus 3bx. Do you see what I did? B is I squared. I squared is negative 1. So negative 1 times 3 is negative 3. I'm sorry, there is no B. I said, did you see what I did? Yeah, I did a horrible thing. Negative 3x. B is negative 1 times 3 is negative 3 times x is negative 3x. C is I, so minus ix. Now I have 2ix squared, negative 2ix squared, so 1, 2, 3, I can exclude 4. Negative 3x, negative 3x, negative 3, I can exclude 2. Minus ix, oh, that's plus ix, so the answer is 3. Negative 2ix squared minus 3x minus ix. Simple, right? Okay. Express 8xi to the 10th minus 4y to the 19th plus 2yi cubed minus 6xi in simplest form. Well, I to the 10, when you divide 10 by 4, you get 2 with a remainder of 2, meaning this is exactly as I said, I squared. And I squared is negative 1. So the first term becomes negative 8x. Do you see that? I 19 to the 19. When you divide 19 by 4, you get 4 times 4 is 16, so you get a remainder of 3, meaning I cube. But we just said here that I cube equals negative I. So negative 4y times negative I becomes plus 4yi. I cube is negative I. Negative times negative is positive, so I get 4yi, not I cube, right? I cube is negative I, so minus 2yi minus 6xi. So I have negative 8x and then plus 4y minus 2y is 2y minus 6x times I. You see, I have I, so I took the I out. What's inside the parentheses? 4y minus 2y, that's 2y, and negative 6x, that's negative 6x. It's just to get used to the fact that I squared is negative 1, I cube is negative I to the 4th is 1, and so on and so forth. Let's look at the next one, and then maybe we'll do the left-hand side, or maybe after the next one, we jump to these two. I don't know. Instead of having a very long session, I know this is the beginning and you don't want to have too many things covered. The expression 3i times ai minus 6i squared, I'm going to distribute that. Let's do it on two steps. 3 times a is 3a, I times I is I squared, minus 3 times 6 is 18, I times I squared is I cubed. I know that I squared is negative 1, so I get negative 3a. I know that I cubed is negative I, so negative times negative is positive 18i. And that is number 3. Okay? It is straightforward. Maybe it's a little light. Let me use a different pen. Oh, we already used that. So maybe in this one, I use that. Okay, let's see if that works. The expression, again, is equivalent to what? I'm going to distribute those. 6 times 4, negative 4 is negative 24. X times x is x squared. I cubed times I is I to the fourth, which is 1. I'm just writing it. And then I have plus 5 times that, so it's 30xi cubed. I to the fourth is 1, so the first term becomes negative 24x squared. The second element, I cube, is negative I, so it becomes I, and the positive becomes negative 30xi. And that's 2, right? Yeah, number 2. Do you see that? I cube is negative I, so the negative times positive and the I. Okay, let's jump to that one. Okay, this expression is equivalent to what? First of all, I have to FOIL x plus 3i or square it. So I get x squared. X times 3i is 3xi times 2 is plus 6xi. And then 3i times 3i is 9i squared. Okay? So that's the first term. Minus the second term, 2x squared, 2x times 2x is 4x squared. This times that is negative 6xi times 2, so it's negative 12xi. And negative 3i times negative 3i is positive 9i squared. And then we are going to subtract. But before subtracting, maybe, well, we can subtract and then see what we get at the end. X squared minus 4x squared is negative 3x squared. All of them have negative 3x squared. 6xi minus negative, meaning plus 12xi, is positive 18xi. 9i squared, which is negative 9, minus negative 9 equals 0. They cancel each other. 9i squared minus 9i squared, they cancel each other. So the answer is negative 3x squared plus 18xi, which is 3. Finally, we have another expression. Let's expand it. 2x minus I squared. It's 2x quantity square, meaning 4x squared, minus 2xi times 2, so minus 4xi. Negative I times negative I is positive I squared. Minus. And then here I have to FOIL. 2x times 2x is 4x squared. 2x times 3i is 6xi. Negative I times 2x is minus 2xi. And negative I times 3i is negative 3i squared. 4x squared minus 4x squared cancel each other. So I get 0. This is 4xi, right? So negative 4xi minus 4xi is negative 8xi. I square is negative 1. Negative 3i square is negative 1 times negative 3 is positive 3. So you get negative 1 minus 3 is negative 4. Be careful with the I square and negative I square. Negative I square is positive 1. So negative 3 times negative 1 is positive 3. So this one is number 1, right? Yeah, number 1, negative 4 and negative 8xi. And basically, that concludes this topic of just understanding what is the imaginary number, how it's used, and then we'll see, maybe we'll take some uh, quadratic equations that when we solve, the answer would have imaginary, and then we see what it means geometrically. This is important to understand, okay? I think I had maybe 1 or 2 videos on that in probably in the math playlist, but we'll have our own here because that's an important topic. Okay, again, if you have any questions, please don't hesitate to comment on this video and I will come back to you as soon as I can. And if you don't have anything, then I wish you all the best and hopefully I'll see you soon. Thank you for watching and have a great day.